The star Betelgeuse, a crimson supergiant in the constellation Orion, has long fascinated astronomers and skywatchers alike due to its immense size and luminosity. If Betelgeuse were positioned where our Sun is, it would stretch out to the orbit of Jupiter, a testimony to its enormous size. Despite being approximately 642 light-years away from Earth, its vast size makes it one of the most luminous stars observable to the naked eye. However, in recent times, Betelgeuse has displayed irregular patterns, such as unexpected dimming and brightening cycles, which many scientists believe indicate that the star is approaching the conclusion of its life. The renowned physicist Brian Cox recently made a groundbreaking announcement that Betelgeuse is on the brink of a catastrophic explosion, expected to happen within the next 2 weeks. This occurrence, referred to as a supernova, will signify the end of Betelgeuse's life but will also provide an unparalleled opportunity for scientists to examine one of the most extraordinary and powerful phenomena in the universe. As a colossal star nearing explosion, Betelgeuse is categorized as a red supergiant, one of the largest and most massive varieties of stars in the cosmos. It has been on the astronomical radar for hundreds of years, but its recent unpredictable fluctuations in brightness have led some to believe that the star is preparing to undergo a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravitational pull, resulting in a massive explosion that releases an enormous amount of energy, radiation, and stellar material into space. The explosion is anticipated to be a Type II supernova, which occurs when the core of a massive star collapses. This core collapse triggers the release of shock waves, radiation, and neutrinos, tearing the star apart. The explosion will be so brilliant that it could be seen from Earth without the aid of telescopes, potentially even outshining the moon in the night sky for weeks or months. While such an event would typically be disastrous if it occurred in closer proximity, Betelgeuse's distance from Earth, about 642 light-years, means that, although the explosion will be dramatic and visible, it will not pose any threat to life on our planet. The event, however, promises to reshape our understanding of supernovae, one of the most significant cosmic events, releasing more energy in a few moments than the Sun will over its entire lifespan. Betelgeuse's explosion will not only be a magnificent celestial display but also a significant milestone for science. Researchers are eager to observe this rare event as it unfolds, utilizing various ground and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much data as possible. When Betelgeuse explodes, it will release a broad spectrum of radiation, from visible light to gamma rays. One of the most important aspects of the supernova will be the influx of neutrinos, elusive subatomic particles that interact very weakly with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion due to their ability to pass through nearly everything without interference. Observatories such as Japan's Superkamiokande and the IceCube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing a head start in observing Betelgeuse's final moments. Additionally, the explosion will yield critical insights into the formation of heavy elements. When stars explode, they produce and scatter elements like gold, silver, iron, and uranium, materials essential for life as we understand it. The examination of Betelgeuse's supernova will provide real-time observations of this element formation process, which is vital for understanding the creation of planets and the universe's chemistry. Although Betelgeuse's supernova is not expected to have detrimental effects on Earth, it will interact with our planet's atmosphere and magnetic field in intriguing ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could cause auroras to be more intense, expanding the regions where the northern and southern lights can be seen. While these cosmic rays could potentially impact satellite communications and some technologies on Earth, the disruptions are expected to be minor. One of the most thrilling aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers. For weeks or even months, Betelgeuse is predicted to be the brightest object in the night sky, perhaps even visible during the daytime. This spectacle will captivate not only the scientific community but also skywatchers and the general public, igniting renewed interest in astronomy and the cosmos. Astronomers have long speculated about the demise of Betelgeuse, but Brian Cox's recent declaration adds an unprecedented sense of urgency. In the coming weeks, observatories worldwide are preparing to investigate every phase of the supernova. The scientific data collected will be invaluable, potentially transforming our understanding of stellar evolution, core collapse, and the distribution of matter in the cosmos. Betelgeuse's supernova will give scientists a chance to improve their models of cosmic distances. Due to its proximity to Earth, it provides a unique opportunity to determine how energy from such explosions travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust in space between stars, astronomers will gain a clearer understanding of the scale of the universe. In particular, the event will provide a golden opportunity to explore dark matter and its potential influence on supernovae. Dark matter, an enigmatic substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it extremely difficult to detect. However, observing the behavior of light and matter around Betelgeuse after its explosion could yield indirect clues about the role dark matter plays in the large-scale structure of the universe. Betelgeuse's supernova will also bring us closer to understanding the life cycle of stars, particularly how massive stars contribute to the creation of essential elements. Supernovae are the primary cosmic events responsible for distributing heavy elements throughout the universe, elements that eventually form new stars, planets, and even life forms. By studying Betelgeuse, scientists will gain invaluable data on how these elements are forged and dispersed. The cultural significance of Betelgeuse's explosion is immense. For millennia, humans have gazed at the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the night sky will prompt philosophical reflection on the fleeting nature of the universe. Betelgeuse has been a constant presence in the constellation Orion for as long as humanity has recorded the stars, and its absence will serve as a powerful reminder of the impermanence of all things. In some cultures, such celestial occurrences have been interpreted as omens or signs of cosmic change. Betelgeuse's explosion may inspire awe, fear, and wonder as people worldwide witness the demise of a star. This spectacular event will likely stimulate renewed interest in space exploration and astronomy, drawing more people into the pursuit of understanding the universe. The lasting impact of Betelgeuse's supernova. Once the initial brightness of the explosion fades, the remnants of Betelgeuse will leave behind a dense and mysterious object, most likely a neutron star or possibly a black hole. The exact outcome will depend on the star's final mass before detonation. If Betelgeuse forms a neutron star, it will be an ultra-dense, city-sized sphere composed almost entirely of neutrons. Neutron stars have incredibly strong magnetic fields and, in some cases, can emit powerful beams of radio waves, becoming what scientists call pulsars. If, however, Betelgeuse has enough mass, its core collapse may result in the formation of a black hole, a region of space where gravity is so intense that not even light can escape. If this occurs, it would provide a rare opportunity for astronomers to study the birth of a black hole in real time, something that has never been observed directly before. A cosmic laboratory for future generations. The explosion of Betelgeuse will have long-term effects on our galaxy. As the supernova ejects its outer layers into space, the remnants will mix with the surrounding interstellar medium, enriching it with heavy elements essential for the formation of new stars, planets, and potentially life. Astronomers believe that such supernovae are the primary way the universe recycles matter, seeding space with the raw materials needed to form future generations of solar systems. Over the coming centuries, the remnants of Betelgeuse will evolve into a stunning supernova remnant, a vast, glowing nebula of expanding gas and dust, much like the famous Crab Nebula, which formed from a supernova observed by Chinese astronomers in 1054 AD. Future astronomers will study this nebula to gain insights into how supernovae shape their cosmic surroundings, helping to refine models of stellar evolution and galactic formation. The psychological and cultural significance. The loss of Betelgeuse will forever alter one of the most recognizable constellations in the night sky, Orion. For millennia, Orion's distinct hourglass shape has remained unchanged, guiding travelers, inspiring myths, and serving as a symbol of stability in the cosmos. However, with Betelgeuse's disappearance, Orion will look noticeably different, marking the first time in recorded history that humanity will witness the reconfiguration of a major constellation. Throughout history, celestial events such as comets, eclipses, and supernovae have sparked religious and philosophical interpretations. Some cultures may view Betelgeuse's explosion as an omen of change, while others will see it as a reminder of the universe's dynamic nature. A global spectacle, bringing humanity together. Unlike many astronomical events that require specialized equipment to observe, Betelgeuse's explosion will be visible to everyone on Earth. For weeks or even months, people from all walks of life, regardless of nationality, age, or background, will share a once-in-a-lifetime experience, watching one of the brightest and most powerful cosmic events unfold in real time. This moment may reignite global interest in astronomy, inspiring a new generation of scientists, engineers, and space explorers. Schools, observatories, and space agencies will use this event as an opportunity to educate and engage the public in the wonders of the universe. Social media will likely play a significant role in capturing and sharing observations of the supernova, uniting people across the world in a shared sense of wonder and curiosity. Looking ahead, the future of stellar observations. Betelgeuse's impending explosion highlights the need for continuous monitoring of other massive stars nearing the end of their life cycles. Astronomers will use data from this event to refine predictions about other potential supernova candidates, such as Antares, Eta Carinii, and VY Canis Majoris, all of which could undergo similar fates in the distant future. Additionally, this event will improve our understanding of gravitational waves, as the collapse of Betelgeuse's core could generate detectable ripples in spacetime. Observatories like LIGO and Virgo will be closely watching for any signals that might emerge from the explosion. The legacy of Betelgeuse's supernova. Though Betelgeuse will eventually fade from view, its impact on science, culture, and our understanding of the universe will last for generations. The data collected from its explosion will shape astrophysical research for decades, offering unprecedented insights into supernova mechanics, element formation, and cosmic evolution. Long after the light from the explosion fades, the elements released by Betelgeuse will travel through space, potentially contributing to the formation of new stars, planets, and even life in the distant future. In this way, Betelgeuse's supernova will not be an end, but rather a beginning, a cosmic rebirth that echoes across time and space. Missions to celestial bodies and other planetary bodies that grasp stars' life cycles are crucial. Additionally, the workings of supernovae are essential as humanity strives to grow its footprint in the solar system and beyond. Additionally, the explosion will ignite enthusiasm for the search for extraterrestrial life. Supernovae play a crucial role in the dispersion of elements vital for life, like carbon dioxide and oxygen, throughout the universe. By analyzing these explosions, scientists can study the detonation of Betelgeuse and enhance their understanding of how life's building blocks may move to other planetary systems and possibly ignite life elsewhere in the cosmos. The forthcoming explosion of Betelgeuse is poised to become one of the most significant astronomical events of our era. Its supernova will yield a plethora of scientific information, enhance our understanding of the universe, and fascinate people globally. While Betelgeuse's demise will signify the end of a massive star, it will also represent the perpetual cycle of creation and destruction that governs the universe, a reminder that from death, new planets, stars, and even life itself may emerge. In anticipation of this historic moment, the world will be gazing at the night sky, looking ahead to when one of the most formidable forces in the universe explodes into view. For scientists and stargazers alike, the final act of Betelgeuse will be nothing short of uplifting. As Betelgeuse nears its conclusion, one of the most speculative yet intriguing prospects tied to its looming devastation is the potential to illuminate some of the universe's greatest unknowns, dark matter and dark energy. These enigmatic forces are thought to account for the vast majority of the universe's mass and energy, yet they remain poorly understood. There is speculation among researchers that supernovae, like the one expected from Betelgeuse, may hold the answers to unraveling some of these enigmas. Supernovae release a tremendous amount of energy and radiation, and some scientists theorize that these powerful forces could interact with dark matter in detectable ways. One fascinating idea is that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs are real, their interaction with the energy generated by Betelgeuse's supernova could provide insights into their properties. Such an interaction would be a revolutionary revelation, offering the first direct evidence of dark matter, a phenomenon that has eluded scientists for years. Similarly, there is potential for Betelgeuse's explosion to clarify the nature of dark energy. Dark energy is the enigmatic force propelling the accelerated expansion of the universe. By examining the behavior of light and energy from Betelgeuse's supernova, researchers may gather important information about how cosmic phenomena like supernovae influence the universe's expansion and how they may connect to dark energy. The impending explosion of Betelgeuse presents a unique opportunity to investigate the life cycle of massive stars, which play a vital role in the cosmic ecosystem. Red supergiants like Betelgeuse are uncommon in the universe, making their examination necessary for understanding stellar evolution. These stars originate from clouds of gas and dust that collapse under the influence of gravity, eventually triggering nuclear fusion in their cores. As they deplete their hydrogen fuel, they grow dramatically and shed their outer layers through powerful solar winds. This mass loss enriches the interstellar medium, paving the way for new star formation. When Betelgeuse goes supernova, it will not only illuminate its own life cycle but also serve as a cosmic laboratory for investigating the conditions under which stars live and die. Researchers will meticulously observe the aftermath of the explosion and the region where a neutron star or black hole may form. The nature of this remnant will provide valuable clues about the physical processes governing the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The shock wave produced by the supernova will sweep through the surrounding gas and dust, heating it and causing it to radiate brightly. This light will give astronomers clues about the elements synthesized during the explosion, including nickel, iron, and other heavy elements. By analyzing spectral signatures, scientists can determine their abundance and distribution, enhancing our understanding of how these elements propagate through space and contribute to the formation of future stars and planetary systems. Another intriguing area of potential discovery is gravitational waves. As the core collapses and the supernova occurs, it may generate ripples in spacetime that can be detected by observatories like LIGO and Virgo. Gravitational waves carry information about dynamic cosmic events, potentially offering new insights into the physics of black holes and supernova formation. Betelgeuse's explosion could also act as a catalyst for advancements in astronomical technology. The expected surge of observational data will likely push the limits of current astronomical instruments. This event may lead to innovations in imaging technology, data processing, and real-time analysis, benefiting a wide array of astrophysical studies. Beyond just the supernova itself, public engagement will be a crucial aspect of Betelgeuse's explosion, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can use this event to inspire future astronomers and physicists. Schools and universities may organize viewing parties, lectures, and discussions to emphasize the importance of understanding the cosmos and our place within it. As we await this monumental occurrence, excitement reverberates through both the scientific community and individuals captivated by the mysteries of the universe. The anticipation surrounding Betelgeuse's supernova encapsulates the human desire to explore the unknown, challenging our understanding of the cosmos while simultaneously uniting us in our quest for knowledge. In this sense, a star's demise becomes a powerful reminder of the creation-destruction-creation cycle that defines the universe, urging us to contemplate our own existence and the mysteries that lie beyond.